So we stopped somewhere here. So regarding space problems, a space problem can be solved by using vector approach, right? So let us start how to what are the steps to solve a particular problem, right? So we will discuss that. So steps to solve space problems. The first one. So whenever you consider, I have any force, right? I have any force, right? Let me consider you have a force like this, which is acting like that, which is having A and which is having B. There are two locations. So force is traveling from A to B. So A is having a coordinate point x1, y1, z1, and B is having coordinate point x2, y2, and z2. In that case, first our aim is to identify position vector. The first step is, of course, locating the coordinate. So locating coordinate points, right? I think I have given a separate assignment for you in locating the coordinate alone. You try it out, you understand the concept, how the coordinates are located. Okay. The second one, number two, right? So find position vector. You have to identify what is the position vector, right? So position vector, we will call it as R suffix AB. So it is traveling from A to B. So R suffix AB vector, right? This R suffix AB vector will be equal to root of, sorry, it is not root of. So R suffix AB vector will be equal to x2 minus x1 I vector plus y2 minus y1 j vector plus z2 minus z1 k vector. Right, this is my RAB vector. Right, what I do, I know what is my final point and what is my initial point, subtract with respect to that. So x2 minus x1, y2 minus y1, z2 minus z1. So this will be my position vector. Right, once I got my position vector, the next step is I have to take modulus of this position vector. The modulus of this position vector is nothing but root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Right? This is my modulus of this position vector. Right? So the next step, so what we are going to do is finding out your unit vector. So the third step is find unit vector. Right? So unit vector is lambda AB. So we will always call it as lambda AB vector. So this is equal to, right, your RAB vector divided by modulus of RAB. Right? That is this one divided by this one. If I consider this as equation 1 and this as equation 2, then it is nothing but equation 1 divided by equation 2. Right? So that is your unit vector. Once you identify the unit vector, the last step is find out your force vector. So find force vector. Right? So force vector is FAB. This FAB vector will be equal to the value of this force, magnitude of the force into, it is actually dot product, it is not cross product because this is a scalar quantity, right, into lambda AB. Right? If I, for example, if this force is 50 Newton, you have to multiply 50 with this lambda AB. Right? So this is the normal procedure to identify for all the forces. If you have 5 forces, for all the 5 forces, you have to do the same procedure. First AB, you identify what is the position vector, what is the modulus of position vector, then unit vector, then force vector, right? And make it as a one equation. So you do this for all the 4 forces, then I can equate it. Then I can say that it is an equilibrium state, which means I can say that sigma fx is equal to 0, and I can say that sigma fy is equal to 0, and sigma fz is equal to 0. Right? It means that It means that, so you have to add all your I components, right, and equate it to 0, J components equate it to 0, Z components equate it to 0, right? So you have to add all the components related to I vector, make it to 0. So you will get 3 or 4 equations. Usually it's 3 equations because you have I, J, and K, right? So sigma fx0, one equation, sigma fy0, one equation, sigma fz0, you will get another equation. So once you got these 3 equations, what you can do, you can use these 3 equations, substitute it, and find out what is the value of the remaining term, whatever they are asking. Right? This is the normal procedure in solving all the space problems. Right? Only thing is locating the coordinate point. There is one difference. There is a little bit difference in one problem. We will also discuss that, and we will solve some problems also. Okay, let me consider this. So it looks somewhat complicated. Yeah. So you have a 1000 Newton container which is suspended in a ring A. So it is suspended in a ring A, to which cable AC and AE are attached. They say that this tensions is equal, which means from F to B, B to A, and A to D. So which means tension in AB is equal to tension in AD. So this is what they mentioned. So sorry, this is separate. This is separate. This is a separate tension, and this is separate tension. So it is connected directly. It is not connected to a single cable, right? So I think the statement is here, over a pulley at B through ring A, right? So that is why they are given a hint in the problem indicating that this is your tension, not this one. Okay, right. So these are the tension force which is acting, right? So there are different types of force. So first I have to identify what is the free body diagram. Before that, my first step is find out what is my direction of each forces. Right? What is the direction of each forces? Right? Let me consider here. So I have considered this A as a free body diagram. A is a point which is having free body diagram. So I have sets of forces. What are the forces? I have W, which is acting downward, AD, A to D, FAD, one force, FAE, another force, right? FAE, another force, and there is another force here, which is FAB and FAC, right? FAC. So these are my directions. So one is acting downward, others are just on the sides of your curve. So it is like this. So W is acting downward. So FAD, FAE, FAB, and FAC. So these are the forces, right? So make sure force is different, tension is different. Tension is the magnitude value, right? For example, if this is P, so these are all P actually. So TAB is P and TAD is also P, right? But this force is different, this force is different because the directions of that force is different. Only the magnitude is same, right? So this is my first step, finding out what is my force on your particular member. Next step is you have to identify what is the coordinate points, right? So you have to identify what is the coordinate points. Let me erase all. Yeah, can you tell me what will be the coordinate point for A, B, C, D, and E? Right? What will be for A? Anyone? It is mentioned this is X, this is Y, and this is Z. What will be the coordinate point A? X-axis. Just look at X-axis. So actually there is a dot here. The dot indicates that it is straight on the origin. If it is straight in the origin, do you have x-axis? No, there is no x-axis. X-axis is 0. You have only y-axis. Y-axis they given. From A, you have one dimension, which is 1.6. So minus 1.6. And the z-axis of 0. Right? This is my coordinate point for A. What about for B? What about for B? B. So x-axis, do you have any dimension with respect to x-axis from B? Yes, you have this dimension.
Minus 0.86.
Yeah, so minus 0.78. minus 0.78, right? Minus 0.78. Y-axis, it is not y-axis. Y-axis is only applicable for A. Others are on the floor, right? So your y-axis is 0. Z-axis, there is no dimension for z-axis also. That is also 0. So minus 7.78, 0, 0. Let me go for B. We go for B. X-axis, no dimension because it is on the line of z-axis, so there is no dimension. Whenever you can able to see any point which is on the line of any axis, only you will have coordinate point for that particular axis. Others will be 0, right? Which means your x is 0, y is also, you don't have distance, y is also 0. Z is alone, you have a distance, so positive z, which is 1.2. You have this 1.2, 1.2. Right? So D, if I go for D coordinate, right? X-axis, yeah. So you can able to see this dimension. X-axis is 1.3. Y-axis is 0. We don't know. Z-axis, it is given. This dimension is given, which is 0. Right? Last E. And I go for E. The x-axis is this one, is negative, so minus 0.4. Y-axis is 0. Z-axis is this one, which is minus 0.86. Right? So these are the coordinate points. You can think about it. So I have used all the points. Right? Mistake, right? So make sure you have to locate all the points. Right? So maybe a little bit confusing. You should look this in 3 dimensions. Okay, so you will get it only by practicing. Right? You try to look at similar problems, similar types of problems. You find out the coordinate alone. Right? If you know that, then it is easy for you. Then the procedure is same. Right? Okay. So O is 0, 0, 0. A is, as I told you, 0, minus 1.6. So B is this. And C is this one. D and last E. So I got all the points. Now, once we got all the points, we have to go for the procedure. For every force, I have to go for the procedure. Right? So every inclined force. So you can able to see this W. W is vertically, it is parallel to your y-axis, right? Downwards. So which means this force I can directly write down. Wx is equal to minus Wj vector. Y is meant for J, so I can directly write down W vector. This force will be minus Wj vector. Why I put negative? Because it is downward direction. Right? Since it is downward direction, it is negative. So this I have indicated. Right? So remaining all the 4 forces are inclined force, which means I have to resolve it. Resolve on the procedure. Right? So position vector, modulus of position vector, unit vector, then force vector. Right? So that will resolve in terms of I, J, and K. Right? Okay. So let us consider the first force, force AB. Right? So force AB, you have A point and B point. I have written it here separately. So what is this? B coordinate minus A coordinate. That is the first step. So when I subtract B minus A, so minus 0.78 minus 0. So minus 0.78 I vector, 0 minus of minus plus 1.6 J vector. This is 0. So this is my RAB. Right? So take modulus of this, root of 0.78 the whole square plus 1.6 the whole square. You will get 1.78. Right? This is your modulus of RAB. Next, unit vector. You have to determine what is the unit vector. Lambda AB. Lambda AB is RAB divided by modulus of RAB. So I have to divide this with respect to this one. So what you will get? You will get this. So minus 0.78 divided by 1.78. You will get minus 0.438 I vector. And this 2, if we divide it, we will get 0.899 J vector. This is lambda AB. Right? Once I got lambda AB, I have to identify what is my force vector. So my force vector is TAB into lambda AB, right? So when you look here, so they already mentioned your AB, AD, and F all are P. So TAB is equal to TAD is equal to P. It is given in the hint. So we are going to follow the same thing. So TAB. Okay, I will write it as TB. Last, I will substitute as B, P. So in order to avoid confusion. So I will write it. So TAB into lambda AB. So multiply with this. So we'll get 0.438 into TAB I vector, and you will get something like this. Right? This is my equation 1. Right? This is my first equation. So I resolved one force now. So let me go for the next force. Force AC. So when I go for force AC, first I want to go for same procedure to proceed. So I have to identify RAC, which means C coordinate minus A coordinate. 0 minus 0, 0. 0 minus of minus 1.6, which is 1.6 J vector. 1.2 minus 0, so 1.2 K vector. So we'll get this 1.6 J vector plus 1.2 K vector. Now take lambda of this, right? Take lambda and proceed accordingly, right? You can also use a formula. Right? This is a hint. So you can use your calculator and you can apply this as a formula to identify directly. I think I think last time we discussed about how to put that variables alpha A, alpha B, alpha C, and all. Right? Similarly, you can create in your calculator so that you can easily calculate AB, AC, AD, and whatever the force directly. Right? So only thing is if you know the steps, you can substitute it and you can find out. Okay. So to avoid to reduce your timing, right? You can also work like that. Okay. Right. So when I put, I will get again lambda AC, which is equal to 0.86, 0.8 J vector and 0.6 K vector. Force AC again TAC into this, multiplying this. This is my second equation. Any doubt in this till now?
No, sir.
Okay. Next one, I'll go for the next force AD. So when I go for AD, so A coordinate, so D coordinate minus A coordinate. 1.3 minus 0, 1.3 I vector, 0 minus 1.6, so 1 plus 1.6 J vector, and 0.4 K vector. We'll go something like this. Again, modulus of this and taking lambda, we'll get lambda AD as this one, right? Then force AD, right? Multiplying with TAD. So we'll get equation 3. Right? Next, last force, force AE. So relating A and E. So minus 0.4 I vector plus 1.6 J vector and minus 0.86 K vector. Right? We'll get something like this. Again, take lambda of this, right? By dividing by modulus of RE. Then force AE. So we get fourth force. Right? Last W, as I told you, it is directly related with, it is parallel to your y-axis. So I can directly write as minus W J vector. You can't resolve that, right? So you can directly write it as minus W J vector. This is my fifth equation, right? Now I got 5 equations, right? Now I got 5 equations. Let me relate it. So these are my 5 equations, right? So I got FAB, I got FAC, I got FAD, and I got FAE, and of course W, right? So I say that it is an equilibrium state, which means I have to add all my I components. So what are my I components here? So I have I component here, I have a I component here, and I have a I component here. These are the 3 I components. This doesn't have I, there is only J. These 2 are J. So these are my I components. Add all this and equate it to 0. Right? Add all this and equate it to 0. Right? We will get one equation. Right? This is my first equation. Next, sigma Fy is equal to 0. When I put sigma Fy is equal to 0, what I have to do? I have to add all my j vector and equate it to 0. So these are my j vectors, right? 0.899 TAB, 0.86 TAC, and all the other things. Add all this and equate it to 0, right? You will get this as an equation, right? Similarly, Fz is equal to 0. Add all your k vectors and equate it to 0, right? These are my k vectors and equate it to 0. You will get another equation. Now I will substitute, right? You know that TAB is equal to TAD is equal to P, right? As it is given in the question, right? So which means wherever I have AB and AD, I have to put it as P, and I can add it also, right? So you can able to see that it is available here, right? And it is available here, and you have only this one, right? Which is P, right? So these are the terms which will be converted to P. When you do that, and of course W is also given. W is 1000 Newton. You can also substitute that. Okay. So we know that you from the equation 1. So this one will give you this, right? When I consider this as P and when I add it, we'll get this. Similarly, this one will be this, and the last one will be like this. So this is equation number 5, 6, and 7. So 3 equations, 3 unknowns, right? You can solve this in your calculator and you can find out what is the answer. You will get what is the value of P, what is the value of TAC, and what is the value of TAE, right? So that completes our problem. There is another problem, so which is a little bit change, right? So where you have to think and you have to resolve it, right? When they give angle and coordinate, so we will be resolving it by using cos theta, sin theta, right? So if you have coordinate and angle both, how to do such problems, right? So let me consider that. Okay, let me consider here. We have a cable BC which is connected to a pipe. Okay, so the tension at BC is given. So the cable BC is having a tensile force of around 750 Newton, right? So this is the elbow. So you have a right angle. So you have an angle here which is 30 degrees. Now, can you identify what will be the force? They are asking what is the tension force P. So they are asking what is FBC. This is the question. You have to identify FBC in terms of I, J, and K. You have to resolve this, right? Okay. So you can able to see there is an angle here, right? This angle is in an axis, in a plane. So you can able to see that this 30 degree is inclined with respect to this Z, something downward, right? So something like that. Okay. Right. In this case, I have to identify the coordinate point, right? So the question is very simple. You have to identify only for this force BC, which means I need only 2 coordinate points. One is C, other one is B. If I know that, then I can easily solve the problem, right? Okay. So if I go for C, you know that C is on a particular plane, right? Your x-axis is 0. You don't have x-axis. Your y-axis is 0.7, and your z-axis is positive 1.2. Right? This is the coordinate for C. What will be the coordinate for B? What will be the coordinate for B? Yeah. Can you imagine? Right? You have an angle. You have an angle here. Right? So B, I can write it like this, right? So your x is same, 1.6. You have an angle here, which means I have to know what is this distance. right? What is this distance? If I draw here this, when I look towards this direction, imagine you are looking in right hand side of this. When you look at the right hand side, so this is my axis, and this is my this is my D point. This angle is 30 degree, and this is 0.8. So I have to identify this distance, right? This distance is nothing but 0.8 cos. Sorry, this distance. Sorry, this is sine. Right? This is sine. Y-axis is sine. This z-axis is cos. Right? So in that case, there is a difference. I think it is 1.6, and your x-axis will be, sorry, x-axis is 1.6. Your y-axis is sine. Right? I think I have made a mistake here. Right? It is not like this. It is minus 0.8 sine 30 degree. Right? And this axis, this is 0.8 cos 30 degree. Right? What is this axis? That is the z-axis. The z-axis is 0.8 cos 30 degree. Right? You will get something like that. Okay, maybe. So you change this, so you will get a different value here. Right? So these are these values for B. Once I got the values for C and D, then what I can do, I can directly find out. Right? So in the angle irukkathanaala, I am resolving it. So I am identifying what is distance and what is your other distance. Right? Once you identify that, you can use the formula. You can identify the position vector BC, which is C coordinate minus B coordinate. You can identify that. Right? You can substitute it. Right? Then RBC, and you will get what is your overall value. Right? So your unit vector, the last, your force vector. So force vector is you are multiplied with 750, you will get this value. So it means that this is your Fx, this is your Fy, and this is your Fz. That is what the question is. You will identify the terms accordingly. Right? Of course, the values are wrong here. We have to solve it again. I think the mistake பண்ணிருப்பேன். So typing mistake. Right? So you have to change the values and you have to put it here accordingly. So, but I hope you can understand the concept, right?
Yes, sir.